Patrick, go.
Hi. Hi, everyone. Very welcome to this very first episode of the webinar series named Extraordinary Architectural Challenges. And first of all, I want to thank Roberto Cuneo for inviting me as moderator. It's a pleasure and honor actually to introduce the very first episode on one side, but this special guest that today we'll talk about a very interesting project in Malta. So Roberto, I let you the word to welcome the guests.
Well, thank you, Patrick. And so, hello to our attendees from all over the world, and welcome to our special guest of today. It's a pleasure to introduce our new series of international streaming that we created for the audience of Medelhan. And the audience of Medelhan, it's basically a business international network of developers, architects, designers, and brands and manufacturers. And with the extraordinary architectural challenges, we want to show and we want to organize a series of meetings featuring the most famous architects in the world, presenting the challenges they face throughout their extraordinary project. And it's an honor today to start this series with Zaha architects, Manuela Gatto, and all her team, and presenting the amazing project of the Mercury House. So thank you, and I hope you can enjoy this webinar. Thank you.
Yeah, before we start and we go deep into the presentation, I just want to remind our audience a couple of things. First of all, that you can request your translation by clicking on the button on your right below where the name is interpretation. The second point is that you can ask all the questions you will love to ask our guests. We'll take some time at the end of the presentation to share your questions with our guests. And as Roberto was saying, we will start the day with Manuela Gatto. She is director in charge at Hadid Architects, and actually there's a talented team with her today. We will talk with Kutz, project architect, Elena Scripelliti, lead architect for Facade, and Xavier Aguiló, engineer. All is about the Mercury Towers in Malta. And I'm very glad to actually introduce this webinar with a project video that we can launch, and then we will start with the first talk with Manuela.
Zaha used to say that she loves Mediterranean city. The reason why she loves it is that it's layered and full of surprises. With our work, we always try to challenge this idea that a room needs to be 90 degrees, a building needs to be a cube, and so on. What we've done with this project, which Zaha personally has overseen at the very beginning, is to precisely bring in a quite clear diagram of how you can take a regular volume of a tower and really twist it, and what happens when you do this. As you approach the project from the various streets leading to the main square, you'll see the tower always under a different point of view, and the twist will represent a constant surprise. Zaha used to say that life doesn't work with 90 degrees. All our work, in a way, is focused in the challenge of what we call the 90 degrees rule. 90 degrees isn't something that happens in nature. In nature, really, what you have is a variety of geometrical constructs. We are confident that this project will trigger new life for St. Julian. We are hoping that it will mean that St. Julian becomes more inclusive and more appropriated by the residents. We tried to design a square which is as wide as we possibly could. It's a moment of relaxation. It's very green. It includes reflection pools, so it's a very nice and calm moment within the busy life of St. Julian.
Great. I hope this was the best start for you to see more visually talking about the project. And before we move to Manuela, I would love to thank our sponsors of today, Alchemia first, together with Glamora, Caimi, and Atmosfera. So I think it's time to talk with Manuela Gatto, Director in charge at Hadid Architects. Manuela, welcome to this first event. I'll let you the word so we can learn more about the Mercury Towers.
Thanks a lot, Patrick. I would like to start our presentation by talking a little bit about Malta, and specifically the area where this project is being built. It's not far from Valletta, so it's pretty close to the real historic heritage areas of Malta, but it's also in the middle of one of Malta's party areas. So it's really, we wanted to capture the sort of mix between historical heritage and party island feeling. The area you can see it marked here in red has represented a big severance within the zone of Paceville, the specific zone of Malta, for many years. It's been unbuilt for a long time. So we designed this project with Zaha just before her untimely passing, unfortunately. So in a way, this project was lucky enough to have the chance to give Zaha the possibility of tangibly expressing her own spatial philosophy. The idea that we introduced is quite simple. So we wanted to just work with a very simple tower block, but giving it this extra twist. And we think this is an interpretation of what Zaha was claiming as a refusal to adhere to a 90 degrees rule. We wanted a project that is full of surprises. And because of this shape, will appear completely different whenever it's seen by through the various tiny alleyways in Paceville. We wanted it to be surprising inside as well as outside. So in the inside, we used the twisting of the tower to provide opportunities for some really unexpected open spaces, such as a pool floating midair and looking down onto San Giuliano. Also, the treatment of the grades, the treatment of the lower levels, it was very important. Paceville is a sloped area, but it's also very densely populated one. So it doesn't have any sizable open space to offer. So we would like this specific square, Mercury House Piazza, to become the beating heart of San Giuliano. So for this reason, we paid a lot of attention in reconnecting the various levels through this sloped site, and also encouraging as much as possible cross-pedestrian circulation. As you can see, the square is located and articulated over 2 levels. The higher level is designed in such a way as to maximize opportunities for people of all ages to enjoy the space, but also allowing as much as possible flexibility of use. And the greenery, in order to allow for this flexibility, we push the greenery as much as possible up onto these terraces, hanging gardens that were designed as expanses of semi-wild vegetation, which is rich in local autochthonous species from the island. So this one is a very complicated area, not only because it's at the heart of a densely populated area, not only because it's sloped, but also because it's dotted with heritage. As you can see here, there is an existing house, so-called, but in reality it's used to be the main telephone exchange of the island. And there's also a number of underground war shelters that have been preserved and reused in our project. The house has been preserved as much as possible. The pink bit that you see here is what was left of the house, and there were 2 longer side walls also in pink. So we took the liberty to kind of encroach the house and involucring the house within the tower, because we felt that it was important to establish this connection, and we didn't damage or alter any parts of the house in doing so. And this house has got this solemn elevation and a bit of a stern look at it, and it's located right at the heart of the busy nightlife of Paceville. So we tried to mediate this relationship by introducing a retail pavilion that you can see in these pictures. The underground wartime shelters, they've been respectively reinterpreted. We turn them into a wellness center with an adaptation that is fully reversible. So at any point, they can be brought back to the existing structure. The restoration of Mercury House also was carried with as much of a light touch as possible. We tried to keep the identity and the material quality of the building, of the existing building. But we also tried to adapt the client's brief to the scale and atmosphere of the 19th century house. So keeping small rooms and preserving everything we could find, the window frames, the doors, and so on. So whilst we really celebrated the presence of this heritage building within the envelope of the tower, we also tried to have a very subtle transition between old and new interiors. So the old and new interiors really blend together quite nicely. You don't really feel much of a threshold. And our, probably people will think, okay, this is not your typical Zaha design, but we did have occasions to deploy our signature interior design language in key special moments, such as this tower twist that we were talking about before, in a number of sky lobbies, pools, and a radio bar at the very top of the tower. This one is one of the bars located mid-level. And this is the radio bar located at the very top of the tower with some breathtaking views of San Giuliano, Valletta, and the Maltese coastline. All circulation space and lower key amenity spaces have been designed quite with, they've been kept quite intentionally very simple. This one is a gym, for instance. In the guest rooms, we had a very close relationship with the hotel operator. They wanted to bring in this distinct Mediterranean themes and feel. So we worked with some clear palettes of harsh timber and metallic champagne tones to bring in this sort of feel of sand and water and these sort of colors. Some rooms, the operator wanted them to be more introspective. So we interpreted this with a completely different palette, as you can see here. Or here, some of the rooms were called, were meant to be more arty. So we worked a lot more with signature pieces from our collections, such as wallpaper and rugs. The suites also varied a lot in size and inspiration. Some of them were very compact, like this one. This is one of the intermediate ones that still enjoy some very special living areas and amenities. We've selected materials, we've selected furniture, so we really went through a very thorough detailing for the guest rooms. This one is one of the living areas for one of the suites. There's a very special suite, which is 150 meters big. So it's really like a large apartment with 270 degrees onto some of Malta's best beaches. For this suite, of course, we selected much more special fittings and fixtures and furniture. It's been designed in such a way to conjure a much more intimate but luxurious atmospheres. And here we really try to kit it out with our limited editions and really make, get this kind of Zaha feeling to it. The development also includes some apartments, which were designed in a very intentionally and in keeping with the client's wishes, very light palette, very luminous and very Mediterranean feel. There's also a 4-star hotel, which is a lot simpler, but it's been designed with the same level of care and attention. Thank you, Patrick.
Thank you very much, Manuela. And, I love to see that in this case, we are talking about a mix of historical and ultra-modern approach to architecture. So we might call it organic modernism. And I know it's a project related to the renovation and redevelopment of an iconic spot in Malta. And actually, this brings me to my question. One of the current trends in design and architecture is hybridization. How does your project respond to the contamination between indoor and outdoor, between public and private spaces?
I think I'd like to talk about how we, as a practice, respond to this, because really and truly, this is something we like to reinterpret. So the idea of a hybrid is something we interpret throughout our work over the years. Since I joined the practice many years ago, 20 years ago, we always played with this idea of hybrid. And in reality, one of Zaha's key design ideas was the integration of architecture and landscape, so that the terrain can become a building and vice versa. So we really like to kind of mix and disrupt building typologies, because we believe in the power of integration. We never ever want to design monofunctional buildings, to the point that if the brief is for a monofunctional building, we'll develop the brief as much as we can with the client, so that it becomes more kind of triggering for mix and occasions of kind of like clashes between different people and between different typologies. So for instance, once we designed, long time ago, we were invited for a competition to design a bridge that was leading over to a pavilion. And what we decided to do, for instance, to put the two things together, we designed an inhabited bridge. And although we contravened with the competition brief, we actually won it. So very often what happens is that the clients maybe don't really, at the beginning, don't really, can't really see maybe the opportunities of hybridization, but when you sort of show them and you get them interested in it, they'll definitely will be able to see that although this patient might be looking a little bit more structurally challenging or a little bit more unexpected and unusual, they really pay off because of their unique nature.
Great. Thank you very much, Manuela, for your contribution. I want to remind our audience that actually this was one of the, I guess, latest concept designs by Zaha Hadid. And talking about the clients, I want to introduce you, Kut, welcome to this episode of the webinar series, Extraordinary Architectural Challenges. I want to let you the word so you can share your point of view with us. Thank you.
Hi. This is from the start of the project. We've been designing in 3D, from Rhino models to Revit models. This is to help coordinate with the design team, and also this BIM work has helped us in the design changes that's been happening throughout the project, but also the challenges that have progressed. Next. The special conditions that we have in the project, especially, have been used in terms of the forms and the details, have been developed to help the contractor and to build the client team to demarcate the spaces and the interiors. These details, such as the podium glazing, will have been, and the supporting steel structure can be optimized for construction. Next. In Revit, the principal forms and details have been developed not only to help the contractors, but also in terms of the forms, in terms of the cladding, the GFRC, and also the actual optimization of the panelization of the facades. Next. As mentioned before, the site has been developed in 2 phases due to the timing of the project site. The client has obtained the phase 2 site, which is to the south of the main tower, at a later stage. The phase 1 is already up to level 33 and has topped out in terms of the concrete, whilst the phase 2 is under construction, and also we are still at design development stage at certain areas of the phase 2. Next. The Mercury House is an architectural interconnection between the new and the old. This is an important aspect, keeping the front portion of the Mercury House and the sides. The internal use has been changing for some time, but now we're getting closer to the built form, and hopefully they can reuse this for the future. Next. The client and his architect is keen to restore the old historic building for the future. Parts of the facade have been restored and are being replaced in certain areas, obviously because of the age. Also now there is a push to develop the balustrade to the historic photographs. So hopefully this will happen soon. Next. One of the historical structures in the vaults is at the moment being developed as health and well-being center, a spa area. We are keeping the confines of the stonework and trying to keep as much of the tiling on the floor with some new minor interventions. We are also keeping a whole section of the vaults which contains communications and equipment for historical record as well. Next. One of the free-formed elements which Manuela mentioned about in her presentation is the pavilion. We've gone through a few variations in terms of the structure of this. However, we have agreed with the client and they have now cast the shell structure in concrete with reinforcement. You can see an image of that. And the next stage will be to clad this pavilion with GFRC cladding, and on the roof of this there will be a mosaic tiling form which will make this as a key element in the project. Next. The tower has evolved during the construction stage with the client making changes not only to the rooftop area to add a pool and radio bar, but also increasing the height. So the height of the upper part of the tower has also increased by 4 floors. This has given certain challenges, but it will also making it more interesting in terms of the views and the roof views at the top. Next. Designing with back engineers, the steel structure of the twist area gives us meaning to the architectural volumes of the pool and the internal spaces. It's sandwiched between 2 concrete structures, one below the twist and above the twist. Hopefully the interiors and the forms will take place very shortly. Next. The rooftop area, level 33, you can see from the images now the pool areas have been formed in concrete. The steelwork is starting to be placed up at this high level to form the radio bar steel structure. We are also providing additional viewing platforms, one with a glass floor, and also a level 30 floor rooftop area will now become a view platform as well. Next. The phase 2 excavation has been now completed. There are 2 images showing just the final completion of the excavation. Next. And lastly, the phase 2 areas, the hotel tower itself on the phase 2 now accommodates the new guest rooms and hotel rooms for Melia. Originally, the rooms were designed in the main phase 1 tower, but now they'll be placed in this smaller mini tower, and some of the room designs will be reviewed with the client team and the hotel operator. The construction for the tower and the surrounds of the main hotel tower, that is at ground level, basement sort of B1 level, the plaza level, and then the rest of the site is basically under construction in terms of the basement areas.
Thank you very much, Kurt. I just want to remind our people watching us now that if you have any question, feel free to drop them down, and we'll pick some of them at the end of the webinar. So you can join us if we want to be interactive. So feel free to ask your questions. Kurt, you're the project architect of the Mercury Towers, and I have a question for you. The project will have a strategic role for the next urban development of the States in an economically significant area, which is St. Julian. What were your clients' requests, and how did you respond, considering also the future socioeconomic development of the island?
I'd like to mention, I think, just on this question, that the client asked us to bring life back to Patcherville, and this we've tried to create, and I think it's already been mentioned before, that we're providing a new urban square at different levels in terms of circulation, making it more accessible to the public. I don't think there are many spaces within this area that have this type of space, and also the facilities in terms of water features, planting. And we also have a food court area behind the Phase 1 tower, which is north of this site, which is at the same level and acting as I think a catalyst for the surrounding areas. I think urban areas that have spaces, open spaces, and also spaces that the public can use are very important for the life of the city.
Definitely, and wonderful to know, because we are actually getting back people around places like this. Good, I thank you once again. I actually want to introduce you now Elena Scripelliti. She is the lead architect for the facade of the Mercury Towers. Elena, thank you for being with us today. I'll let you the word to introduce actually your activities on the project.
All right, thank you very much, Patrick. So in terms of facade installation, this is where we currently are. On Phase 1 tower, we started installing the GRC cladding up to level 25 and the sliders at the balconies. Being this fast track design and build project, we are in the process of finalizing the design and shop drawings for the complex areas. On the shore facade, we are using unitized system panels. The shop drawings are approved and the panels are in the production at the moment. As you can see, the contractor have already started installing the brackets to support the panels. Next, please. At the very beginning of the construction stage, the facade contractor produced a preliminary mock-up of the balcony, of a typical balcony, testing the various elements of the design. So we were basically able to try out different color schemes and to see the lighting effect of at the GRC strips for the first time. Let's say this was our starting point for several refinements that came on a later stage. Next, please. Going a little bit more in detail, the main architectural features of the tower are the heavy shot blasted GRC strips coated with waterproof and anti-graffiti neutral sealant. We also have two lateral cavities at each strip that will allocate the LED luminaires to lit up the tower. So the intent from a design standpoint is to create an interactive lighting show at nighttime. This was specifically requested by the client and carefully studied with tests on site. Next, please. The facade contractor installed an on-site mock-up of a typical balcony with low iron glass balustrade, an aluminum fascia covering the balcony slab, and glass sliders. They are planning to complete it soon by adding the balcony tiling, the waterproofing, and the render boards on the side. On the shore facade instead, the contractor produced a mock-up sample of unitized glass panel for approval and general quality check. We had quite a few challenges on this area, as after survey, the contractor found clashes between the design cladding and the concrete transfer structure. Therefore, we had to, before production, the contractor ran performance tests at their facilities, like, for example, water, acoustic, and wind dome tests. Unfortunately, at the time, we were not allowed to travel due to the pandemic breakout. So we could only follow up in real time all the tests via Zoom. Some of the performance mock-up were used to visually validate and agree the unitized system frame's appearance and spandrel colors. So this is the twist. We are also in the process of concluding the design drawings with the facade contractor. We have finalized all the material selection so far, and the contractor have produced a mock-up for the steel and glass facade facing the suspended pool area. In general, we are currently in the process of approving and validating all the technical aspects of the mock-ups. Next. As you can imagine, we have been facing quite a lot of technical challenges, starting from the geometry and drawings for the whole twist area, which, I mean, you know, certainly present complex details and interfaces. Then the rotation of the tower led to a specific facade access and cleaning strategy. So we opted for a portable BMU at the rooftop, and the upsailers will sail down and hook anchors placed at the twist area. Also, the position of the crane are causing installation issues at the corners, and the contractor will likely install the leftover panels after dismantling the cranes. And I should also mention that due to the pandemic, the contractor had quite a lot of procurement issues in terms of material, so we had to investigate replacement in a very short time frame. Next one. And yeah, then to conclude, the next steps will be finalizing the facade design for the tower podium and twist and the rooftop in general. And in parallel, we are aiming to conclude DD on phase 2 in the next couple of months, and carrying on with all the concrete works and excavation. So the estimated completion dates are end of 2022 on phase 1 and 2023 on phase 2. Thank you.
Great. Thank you, Elena. And I have a question for you, which relates to the facade topic. And I know, of course, that Paceville is on a Mediterranean island. So I want to ask you, how did you approach the problems of direct exposure to light and windy climates in designing the tower?
I would say that there were several key factors taken into account, you know, during the design phase, plus some additional ones that a bit more technical that were implemented later. So, for example, from a solar control standpoint, mainly the balconies were designed in a way the maximum shade was provided, both horizontally and vertically. And going a bit more in detail, in terms of heating control, we are using a high selective low E coating to, you know, provide sufficient thermal insulation without affecting the natural light transmission. In terms of wind protection, instead, we had external consultant running a few wind tunnel tests to ensure each area was designed in a way that maximum comfort was provided for all the occupants. So, for example, at the rooftop where we have the maximum wind exposure, we had to introduce a 2-meter high windscreen. So let's say basically in general, the whole cladding was designed to resist to the local wind loads.
Great, thank you. Thank you for sharing your feedback and information. It's time to meet our last and fourth guest. We will talk soon with Xavier Aguiló, who's dealing with the engineering aspects of Mercury Towers. Welcome to this event, Xavier. I let you the word again, and we're very curious to know of course, also the aspects related to your role in this project.
Thank you, Patrick. We are engineering consultancy, and we took part of this project from the very beginning. We were in charge of the structural analysis for the tower in phase 1, so the one that is shown in the images. And for phase 2, we are doing the structure and as well the MEP for the MEP sustainability for the hotel tower. Next slide. As you know, this building is a very challenging building because at least phase 2 is, let's say, a high-rise building. It has some challenging aspects. There is a twist, there is a transfer, there is quite a lot of things. But I would like to show some big numbers that we could collect about this project. So we have 18,000 cubic meters of concrete, which is quite a lot, honestly. Close to 7 million kilos of steel reinforcements, and then 240,000 steel structure, kilos of a steel structure for the steel elements that we have on the tower. Mainly the building is based on concrete, as I said, but some of parts of the building has to be solved with this steel structure. We have 33 floors plus the canopy on the rooftop, and then we end up with 262 residences. At the beginning, we were planning to do a hotel, and then end up with these residences. We have 2 pools, one in the middle of the twist, which is one of the reasons why we have the twist there, and the other one is on the rooftop. And then, of course, we have the twist of the building, which is the main characteristics of it. Next slide. So the tower that we have in front of us is being built. So right now we already are finished with the structure, and we are doing last works. But at the end, this tower with the 33 level, we will be the highest point in Malta. So it will be the tallest building. And that's quite challenging because it's not an island where you can find lots of high-rise buildings, except the one that we have here in the picture. So that's an interesting milestone. But we know that there is in planning another building that will be taller than that one. Next slide. So the tower that we are showing has a twist in the middle, and probably some of you will wonder how we deal with the cores and with the vertical elements like the elevators, like the stairs. So in that case, as soon as the building twists, the cores kept twist, of course, because they go straight. And then to ensure the capacity of resist the horizontal loads, the seismic loads and the wind loads, we place these shear walls that in most of the cases, they are the division between rooms. The shear walls are the ones that surrounds the cores, but as well the ones that are in color, in red and yellow, that tries to connect the core with the exterior columns. So in that case, the stability of the tower is reached by the binomium between the cores and the columns. Next slide. A building like this has different ways to approach, but one of it is very, very important, is to understand and see which is the stability of the building in terms of vibrations. So because that's a cantilever and the building has 33 levels plus 6 basements, that's a building that at the end is 39 levels, okay? The basement in that case are not stuck against the ground, so that means that the tower needs to resist the whole height itself. So we did an analysis of the vibrations to understand how the building performed. And with this analysis, we make sure that everyone that is in the tower, even if it is at the highest level or the lowest levels, they will always be in comfort. That's our milestone. So if we move to the next slide, these vibration modes were analyzed in with the wind loads. As Elena said, we did this tunnel test that you can see on the picture. That's a tunnel test carried out in London. And this tunnel test was key to understand what was the performance of the tower against the wind loads, but as well to determine which was this wind load that we need to consider in this island, because the local regulations tells you somehow which is the wind load that you need to consider, but not at this level. So we come up with a very low force of wind, so that keep us a very, let's say, less quantity of reinforcements that we plan to give to the tower. Next slide. And that's the basements, let's say. So that's the excavation that we found when we arrived to site. As you can see, everything is excavated like vertical, because all our ground, let's say, or our plot is like a rock. It has to be dig with a disc and cut. And it's quite interesting to see how the existing Mercury house, the heritage one, is standing there. And there is a fall of 6 levels down where we start doing the basement. The basement or the foundations, so the foundations level is made by footings. Some of them are bigger, some of them are smaller, but at the end they are isolated footings because the ground is quite capable. Even though these 6 basements are limited because we were at the same level of the sea. Next. Then I want to introduce the different challenges of this tower. As you can see on the left, we have the twist. The twist is probably the most the most exposed challenge that you can see on the building and the characteristic of it. And it was, in fact, a big challenge. Then we have below in cyan the colonnade. That's a gesture in terms of architecture to have a better understanding of the building from the plaza. Then we have the transfer, the red one, that is transferring big columns and big loads on top of the Mercury house, the existing one, and respecting it. And then we have the canopy on the rooftop, which is probably the biggest span structure that we have in this building, with close to 30 meters span, so it's quite a lot. Even though, despite this big span, the most relevant one is the wind loads that we will have at this level. Next slide. So here we have some pictures about the twist. As you can see, it is made by steel structure. The steel structure covers the 3 levels that embrace the twist. So the twist happens in 3 levels. And in these 3 levels, we reach cantilevers close to 9 meters, which is quite a lot. The steel structure that you can see is mainly the one that is exposed, but there is another one on the level above and the level below that is inside of the concrete columns, just to transfer the load that is coming from the steel structure. This steel structure has many responsibilities. One is to transfer the vertical loads, but the other one is to have enough stiffness to keep the building on place and transfer the horizontal loads to lower levels with not too much problems. As you can imagine, whenever you have a twist structure, the problem is that this twist structure can twist more, and that's what you need to keep on place. Next slide. So in that case, as you can see, the building is shifted, and there are some internal shear walls that we already saw on the pictures, and then we have as well this pull on the twist that don't allow us to place a steel structure there, because we want to have clear views and no non-structure that bothers the views. So in that case, we have another transfer structure from levels above that avoids this load going down. So in additional of this, let's say, twist, this 15 degrees twist, we have this void to allow the place of the pool. Next slide. Another challenge one was the transfer on top of the Mercury House heritage building. This transfer was quite challenging as well, because we have all the load coming from the upper levels to this level. So we need to define a transfer that moves all these loads to the exterior columns, and at the same time to have enough space to keep the levels as a regular building, because all the levels of this building is still there. We decide to go for this type of structure, that we transfer the loads with an inclined column, and this inclined column has a hanger that hangs the existing levels that we have below, just on top of the Mercury House. And on the right, we can see the colonnade. The colonnade is as well a quite challenging things because we are just on the lower level and we have to divide the load that is coming from the upper levels to columns smaller than what is coming from levels above. And this opportunity for the structure allow us to have a better space in the plaza. And then the canopy on the rooftop, that it's a canopy of close, well, I think that it's 27 meter span. That will be built in the recent months, and probably is a very interesting structure because it is not only having this span of 30 meters, but as well transferring all the load to the concrete structure, but not on the columns that are below, just to an element that transfers all this load to another column. So it's in itself a challenging element. Next slide. And then just to close the presentation, here you have the picture when we arrive to the 33rd level of the tower. That's the crew of people that is working in this project. And of course, we are very happy, not just to finish, but as well this amazing view from the Malta and Valletta and San Julian and the sea and everything. So thank you very much.
Thank you, Xavi. Glad to see all the components of a project like Mercury Towers. And I have a question for you. You are an engineer from Back Engineering Consultancy Group, and I know that you are fully engaged with the integration between technology on one side and, of course, architecture on the other. And I know you already touched these points, but I would love to know what was, in your opinion, the biggest and most stimulating challenge that you faced in the case of the Mercury Towers, considering also the iconic and historical place that we are talking about?
So I would say that in that case, all these challenging points that I highlight on the presentation were integration of architecture and engineering. Of course, in that case, the challenge was how we adapt the structure of this building to the architectural, let's say, needs or milestones. The twist is one that it's very important because that gives the identity and the iconic of the building. And that was probably the first one that we tried to solve as easy as possible. The client was worried about the steel structure because it's not a material that is used to work in Malta. But at the end, they made that very well. They have some suppliers from Italy. And then the other one that probably was more challenging and was difficult to understand from the very beginning was the colonnade. Because as you can imagine, that's a very challenging building as soon as you work with the fast track thing. So we were developing the project, we were end up with the dimension of the columns, and then suddenly Zaha requested us to reduce the columns on the colonnade, on the plaza, just to make them a little bit smaller and more interesting for the space. So it's this kind of things that you need to readapt, be very absorb in terms of architectural needs, and then try to change and try to find the best of you in terms of engineering to find a solution.
Muchas gracias, Xavi.
Yeah.
I have a question for Manuela, and we will go to the end of this webinar with this question for Manuela. I wanted to know, and we got a question from the audience. We wanted to know what was, from your point of view, since you have a huge experience at Hadid Architects, in this case, what was the, let's say, the most interesting challenge that you faced in this case due to the multifunction approach of the Mercury Towers? You were partially answering before, but maybe there's something that you would love to underline at the end.
Yes, I think we posed ourselves some challenges, which I tried to explain earlier, the fact of making the structure more interesting, but also more challenging, accommodating uses between in these special moments. But I think one another challenge for us was also not only putting together all the architectural pieces, but also putting together all the parties involved in this project. the client, who is also the developer, but also the contractor building part of at least part of the project. So the client is a contractor, the client is a developer, all the stakeholders I had both within the project, because some of the part of the project consists in apartments. And so the project went through the usual process of pre-sales, to kind of like to fund part of it via pre-sales with so that you started having a lot of more stakeholders and other people actually buying part of the project at the early stages. But also, of course, the operator is an operator that we worked with in the past, we worked very well with. But of course, the more it's Melia, the more high-end the operator, the more the kind of like requests and the kind of coordination you have to set between your design intention, their design intention, and so on. Of course, I think we work very well with everybody, but the level of coordination that all of this required from all of us, from the team, the engineers, the architectural team, the client side, operator side was notable. Another thing is that when we started the project, as Travis pointed out earlier, the site was completely excavated. So we were still doing SD. So we're still working at early concept stages, and the client was already asking for construction drawings for the basement. So we were like, it started off as a really kind of mad fast track project, to the point that I interrogated the project manager as a consultant at the beginning. I said, is this feasible? And they told me no. But actually, it was feasible. We managed to do it.
That's a good start. Very good. Wonderful. Thank you very much, Manuela. And I think we got to the end of this webinar. And I want to remind the audience that this was the first one of the series, Extraordinary Architectural Challenges, which is developed, Robbie, correct me if I'm wrong, with Marisa Corso. So I want also to share my congratulations with Marisa as well. And thanks once again, Alchimia, Glamora, Caimi, and Atmosfera, which are the sponsors of this episode. So Roberto, I give the word if you want to conclude or add anything to the webinar. Of course, I thank you once again for inviting me as a moderator. I guess you're muted, Roberto. Yeah.
So I have to say a big thank you to our guests of today and to our attendees who followed carefully this event. And I need also to say a word about the next event, because thanks to the work of Marisa Corso, that is curator of the series, we can already announce that for July, the next episode will be held and we will have as guest Stefano Boeri, presenting another amazing project in July. And then I just want to remind only that this video will be available on our YouTube channel, and nothing else. I hope that everybody enjoyed this event, this international streaming. And again, thank you to everybody.
We wish the best luck to Manuela, Kut, Elena, and Xavi for the project. So it's been a real pleasure to be with you today. Thanks again.
Thank you. Thanks, everybody. Thanks, Patrick.
Thank you.
Roberto.
Thank you. Bye-bye.
Bye-bye. See you soon.
Bye-bye.
Thank you.
Bye.
Bye-bye.